Join us and discover the magic of virtual product validation, where the impossible becomes possible and your design comes to life. Get ready to be amazed and learn how SolidWorks CAD and simulation can take your products to the next level. So without further ado, let us have a look at today's agenda. Starting with introduction to capabilities and ease of use with SolidWorks CAD. Next we have streamlining structural simulation with SolidWorks and streamlining design for maximum performance and durability. And in the end, we will have a question and answer session based on the current session. We are authorized resellers for SolidWorks in both Andhra Pradesh and Telangana. Coming to our company, Logical Solutions. Logical Solutions was established in the year 2000. Back then, we started with 4 core people. Now we are 50 plus employees. We received so many awards in our journey towards success, like top resellers in India, 100% Sales Club Awards, and Top Best Marketing Award, and Educational 100% Sales Award, etc. We personally have sold 1050 plus licenses to 450 plus customers, 6500 plus licenses to educational sector, etc. And we also take up projects in CAD, CAM, and CAE fields. So typically, in industries, the design process starts with CAD. So let us have a look at some of the SolidWorks 3D CAD advantages. Starting with part design. In part design, we can create an entire 3D part, apply material, color, and get meta properties like mass, volume, moment of inertia, surface area, etc. and rectify any errors before even going into manufacturing phase. Once the part once the part is complete, 80% of the work is completed, and it is very easy to create an engineering drawing by just few drag and drops, where we can take advantage of automatic view placements and automatic dimensionings of the part. Once the part drawing is completed, we will assemble all the individual parts in assembly environment, where we can create assembling and disassembling videos for better visualization of our assemblies. So once the assembly design is completed, we create assembly drawings, where we can take advantage of automatic ballooning and automatic bill of material generation and seamlessly create assembly drawings. In the end, we can take advantage of e-drawings, which acts as a 3D viewer to view the 3D models and conduct markups for effective communication when you are working with a team. For the next few moments, let us see how easily we can create parts drawings, assemblies, and assembly drawings in SolidWorks. Let me go to the SolidWorks. Let me open the bicycle assembly. So I'm using this bicycle as a reference to show it to you how this crank is designed. So currently you can see here the crank is placed in this side. So I have to create another crank over here. So I'm creating new part. Let me just create a new part. So what we are doing now is creating a part within assembly. So this is top-down assembly. So we can easily use shortcut bars to get all the tools instead of going again to the command manager tabs and getting confused. So I want a circle over here. Okay. So now what I want to do is I want to trace these edges. So I'm converting these entities. Using okay. Now let us add material. Let us see how we can add material. So when it comes to SolidWorks is user-friendly software. Like everything is highly customizable in SolidWorks. You can see each and every command manager tabs are properly organized for new users to learn and increase productivity. Like you can see, there is features, and in the features command manager tab we have all features which are related to adding material, removing material, etc., patterns, etc. And when it comes to surfaces or sheet metals, you only have those set of tools there. So it is completely organized, and for new users it is very easy to understand. Let me just make a small correction over here. Let me edit the sketch. So we are already in an edit of the sketch. So let me convert this edge as well. Now let us add material with boss extrude. So like this we can create a part within the assembly. So let's just go back to the presentation. So here, as I told you, everything is organized, and you can also take advantage of this hole wizard features. Like it has more than 1 million set of standards of holes, the counter bore holes, countersunk holes, straight tap holes, according to different standards. So it will lessen a lot of time for designers like us. You can easily make use of this mouse gestures. So let us go back to the presentation. Now let us see how easy it is to create drawings, part drawings in SolidWorks. So let us draw this crank. I have already one drawing. You can see I have already created a drawing easily by just going to file, make drawing. So let us just create a section view. So easily you can detail the drawings, and here you can see in the drawings it is very easy to just drag whatever view you want and just place in the sheet. Okay, that's how simple it is with SolidWorks when we compare it with other softwares. Okay, so now you can easily dimension them. You can use this mouse gestures here. You can dimension this. Okay, and you can also see the hole wizard. By using hole wizard holes, we have created a feature, and you are getting very good text automatically. Okay, let us just go back to the presentation. So like this we have created a part design and part drawings. So we have let us just summarize what are the advantages in part design. Starting with simple user interface. So as I told you, SolidWorks is a very user-friendly software. We have so many customizations in it. You can take advantage of shortcut bars using S key. D also you can use to exit anything and give you an in-context options. And you can also use mouse gestures and customize your entire command manager tabs according to your needs. But even though SolidWorks will give you a preset of command manager tabs which are very organized, and it will showcase you beautiful animations and detailed text for better understanding of the particular command. As I told you, everything is organized. Like, it is very easy for new people to learn SolidWorks because everything, the user interface is very simple to understand. Okay, you can take advantage of these hole wizard features. As I told you, there are so many sets of standards, so the user might get confused to research any standards and get into his design. But instead of that, SolidWorks will give you leverage your design and in more faster way, like with hole wizard, where you'll have so many counter bore holes, counter sunk holes, straight tap holes of different standards. So it will reduce a lot of time. And when it comes to part drawings, you can take advantage of the automatic view placements. Like within few clicks only, you can place the views from view palette, which is on the right side, and place it in the sheet and get automatic dimensions. Whatever dimensions you have used to create the model, all those dimensions can be populated on the views automatically with just one click. So that is the advantage of using part drawings, and it will be very quick. Okay. Dimension placements. All the dimensions which you have populated in the view can be automatically arranged within just few clicks, within just one click. So with all these advantages in part designing and part drawings, we can avoid a lot of drawing errors. Let us see in a moment how we can easily create SolidWorks assemblies. Let's just jump into SolidWorks assembly. Let me open the assembly. Here let me take this reference. Let me just copy it. So it is very easy to position any component in SolidWorks. You can use the mates to constrain the degrees of freedom. As you can see here, I'm using concentric mates. Just select two things and apply concentric mate, and select these two faces and apply coincident. So applying mates will fix this component. As you can see, now my crank is completely fixed. So easily in assembly, you can use smart fasteners, which is a very effective tool. If you never know about smart fasteners, it will leverage the power of toolbox in SolidWorks, where you'll have so many standards of nuts, bolts, and fasteners. Let me show you where the toolbox is. So here there is a toolbox and different standards, and each standard we have multiple sets of bolts, fasteners, and O-rings respectively. We can select base. It will automatically identify the pattern, and just by clicking add, it will automatically recognize all the things which are done in one feature, and will give fasteners to it. So if you are not willing to place this type of fastener, you can always change here, change fastener type, and choose whatever fastener you want. Just by selecting here, okay, so it's already changed, and click OK. So this is how easy we can use the power of SolidWorks toolbox and easily do the job, complete the job. Okay, and also you can make take advantage of some different set of tools in assemblies. Like if your assembly is having moving components, you can use motion study to evaluate the physics of that moving components. For example, if you have any gear or else the crank rotating portion, if you want to analyze it, you can easily do it in motion analysis. And if your assembly is having any moving interfering components, then you can always evaluate with interference detection, which will tell you and give you a detailed Excel report based on where are the interference and how it has to be rectified. And similarly, clearance verification and hole misalignment, which generally occurs in the production. Okay. So finally, when the assembly is completed, you need to showcase it to non-technical people. Like if this is a product and non-technical people also, most of the people will use this. So for non-technical people, they have to understand how to service this or repair this. So they have to understand how the each and every component is moving out, coming out, what is the way it has to be arranged. So for that, we can easily use exploded views in SolidWorks assembly, and let me show you how to create that. Just by going to assembly command manager tab, you can see here we have exploded view. So let me just select these 4 components. by using the triad. Just let me open it. I just forgot it to select this one. Let me select this one as well. You can see automatically it is here. After selecting, let me just select done, and then I'll select another component and use the same triad to perform the same action, and done. Click OK. Now the explode which I have created will be integrated with SolidWorks drawing as well. So it will be automatically shown in drawing as well. So here also we can animate this and save it as video. You can see the animation, and here we can also save the video into any format and any number of frames, and also render it. Okay. So now let us just go back to drawing and see whether this has been added in there or not. Exploded view 1, you can see here. And let me just go to drawing, and I'm going to find and make drawing from assembly. As I already have created a drawing, I'm just clicking yes, so that drawing will be opened. Okay. So let me just delete this one. Just refresh here. So here on the right side, all the views in drawings will be populated. No matter what, whether it is a part or assembly, it will be populated on the right side, which is called as a view palette, and entirely together it's called task pane. So let us just go down here. You can see isometric exploded view. Let us just drag and drop that view and place it here. You can see here, it's on the other side which we have exploded. So if you want to just change this, we can make small changes instantly here. Okay. So simply we can just with few clicks only you can create the bill of materials, and we can also create the automatic ballooning list. Just identify the exploded views, what are the components. So this is just an example. You can see how I can use I'll use this automatic balloon option, and you can see how beautifully it has given me all the things. So this is the power of SolidWorks. Okay, so let us just go back to presentation. So like this, we have created assembly design. We have used mates to position the components. We have also created the detailed drawing of assemblies, and we have seen how automatic ballooning and automatic bill of material helps us in fastening up the process of assembly. Okay. And you can also use multiple things in assembly design to restrain the degrees of freedom. It will act accordingly. Now let us just brief out the advantages of assembly. So starting with simple placement and positioning. So whenever you position any component in SolidWorks, you have the default triad by which you can rotate it in any axis. And also you can use mates to position it, and you can also use planes and axes to position it if it is a step file. Then you can also take advantage of toolbox, where, as I told you, there are over million standards nuts, bolts and fasteners already there installed in default SolidWorks. And that is a very good thing, and you can use it to reduce the time. And next, if you have any moving components in your assemblies, you are working with gears or else shafts, and you need to create a perfect motion of it with respect to time. So you can do that seamlessly using SolidWorks Motion. You can create various plots of acceleration and velocities with respect to time, and evaluate where the component's reaction force is more, and ultimately evaluate the assembly. Okay, next we have automatic bill of materials and item balloonings. This is a game changer when it comes to designing and giving faster drawings. It's a game changer. We can make use of these beautiful options in SolidWorks. Let us see some more advantages of SolidWorks CAD software, starting with design automation. So design automation is like when you have a design which is already completed and you want to automate it to meet the customer's standard of, you want to create a different variation, then you can use SolidWorks effectively by adding equations power to your assemblies. Okay, in equations you can use any number of things. If you are aware of if else loops and int conditions, integer return values, your design no matter what will give appropriate values and behave accordingly. So it is entirely dependent on how you give formulas, what based on what length or you constrain your patterns. It is based on all those things. And next we have API macro customization. You all know that SolidWorks is powerful when it comes to usage with Excel. So it is just limited, but if you know API macro customization and you know VB.NET programming, then I can say that you can just play with SolidWorks. Like you can just do everything in a conventional way, how our age-old mechanical engineers used to do in Excel. Next, cost estimation. So in cost estimation, SolidWorks will give you just beautiful tools, adjust your design tips. Like this, you can easily create evaluation of your assembly based on the cost of the material and the labor and whatnot. You can include each and everything in the template and just add your margin and give your cost estimation, and it is very useful. Okay, and next we have 3D interconnect. So if you are someone who is working with multiple CAD systems and feeling that SolidWorks is easy to work, so you are right. SolidWorks is easy to work when it comes to other CAD systems as well. So you can import any CAD systems file directly in SolidWorks and start working on it. It's so easy, and the best part is if you import and work on the imported file, and if you make any changes in PTC Creo or else Solid Edge or CATIA, the same changes will be applicable in SolidWorks also. That is the two-way integration is possible now using 3D interconnect. Next, apart from this, we have some more advantages using SolidWorks. Now SolidWorks is giving complete ECAD and MCAD solution. Electrical CAD and mechanical CAD is now integrated with SolidWorks CAD and SolidWorks Electrical, which is again an added application. Okay. Now we have integrated piping and tubing, including with electrical wiring. Everything like ducting, harnessing, everything is possible in SolidWorks. Next, we have design standard checker. So design standard checker is again a beautiful tool in SolidWorks which will help you meet the standards of your drawings. So let me just give you a small example. Like if you have a drawing which has some set of values, like the values in the sense, what is the font of section line, what is the font of the annotation which is going to be used, what is the font included in the title. So those things are meant to be kept standard. So if you want to check all those standards and feeling very tired to check it for hundreds of drawings, then design standard checker is a game changer in that. You can use design standard checker tool to just change everything from one click. Okay, with one click you can change everything to your standards. And next, coming to the animations and rendering. So when your product is complete, you have to create animations to make presentations and finally render the product to showcase it in the browsers. So you can use SolidWorks Visualize for that. It is a very good tool and is integrated with SolidWorks CAD. That's a beautiful thing about it. It is integrated. So whenever there is a small change, you don't need to again create a busy scheduled hours to just render it. It is automated. Okay. And next, coming to the task scheduler. So every designer has a lot of work to do in his bench. So task scheduler can schedule your tasks similar to Windows task scheduler. it will schedule the task related to SolidWorks, like conversion of the files. Like if you want to convert the STL files into SolidWorks files, designers use so many STL files. So instead of again opening it in SolidWorks part and saving it as SolidWorks part, task scheduler will lessen the time and convert thousands of parts in just seconds. Okay, so this is a game changer when it comes to non-productive hours. You can set task scheduler in non-productive hours when you are not working, and you can see that when you are just at your desk tomorrow, it is done. So that is a beautiful thing about task scheduler, and hope everyone will leverage the power of it. And standard toolbox library, as I already told you, standard toolbox library is a beautiful set which is very helpful for designers. You have so many standards, hex bolts, different types of bolts are there. You can also download different standards of parts in toolbox library apart from the standard ones. And next we have interference detection. So many people are frustrated of designs with interferences. So SolidWorks interference detection will just help you, like you will feel very encouraged by using interference detection. It will just give you an Excel report simply telling you which components are interfering, what is the volumetric interference, and how you can take actions to reduce them. So it is cool. And next, coming to motion analysis. As I told you, motion analysis, you can apply motors. You can see what is the acceleration or velocity with respect to time individually, or you can mix those plots. You can export it to Adams, which is an industry standard motion analysis tool, and so on. Like if I sit here and just list out all the advantages of SolidWorks CAD, there are so many. There is no number. Now let us see whatever design we have created, how this can actually fail. So these are the images how it can actually fail in real life. And let us now inspect which crank will last longer. So the main problem with the design of this crank is durability. How many hours is it going to be sustained? Like what is the lifespan of this crank? So that is our concern, and of course the concern cannot be fulfilled just by structural analysis. So that's why we are employing some method, some more methods into it. So let us just go into SolidWorks and see how we can set up a study, structural analysis, and in a hands-on session. So now you can see here, in this study, you can see we are applying force of 1350 Newton. You can also apply pressure, but force is a convenient way of applying. So that's why we are applying 1350 Newton on this pedal face. And let us see which version actually of the component is sustaining a lot and giving us more life cycles. So minimum what we are expecting is it has to sustain these many cycles. So now let us jump into SolidWorks. So this is our crank assembly. Now let us create a new simulation study. So as you can see, simulation is already added. I'll just go to, if it is not added, you can just go to add-ins and add simulation over here. So once the simulation is added, you can create a new study and static analysis. Click OK. So you can see static study 4 has been created, and you have some parameters to define actually. So in static analysis, not only in static analysis, in any type of analysis, we need to provide the material of the component. Here you can see the material which I am giving is 6061 alloy, that is the aluminum alloy, 6061 aluminum alloy. And here you can see some parameters are in red color and in blue color. So it means that red colors are compulsory to define, and blue color are actually optional things. So based on the study, these things will take into consideration: tensile strength, compressive strength, based on the loading. Okay, so once we can apply, we'll close it, and next, after applying the material, we'll see what are the connections necessary. So for this study, I'm letting the SolidWorks do its job. Like, SolidWorks will define it as a global interaction. Okay, so I'm just leaving it in the global interaction way. So SolidWorks will understand that, okay, this is the interference of the component, where these two things actually touch to each other. So it is a global contact. So I'm just leaving it as a global contact. And now we have to define the fixtures. So we have so many fixtures over here. You can see fixed geometry, different types of roll. So these things actually constrain the model in 6 degrees of freedom. Like, fixed geometry is 6 degrees of freedom, and roller geometry will just constrain only one along one axis. Similarly, fixed hinge, rest of the things are there. So for this study, I'm just selecting fixed support and selecting these holes to be fixed. Okay, so now it is fixed from this end. Now I'll apply load on the pedal. So let me just add load. So here also you can see there are so many ways of adding load: force, torque, pressure, gravity, centrifugal force, bearing force, temperature. So whatever is applicable you can apply. For this study, I'm just going with force and applying 1350 Newton. Okay, if you want to apply newtons, you can apply newtons, or else if you want to apply per kg, you can go to IPS standard. Okay, sorry, metric standard. You can see kgf. Okay, and click OK. So here it is asking me to select face. So I'm selecting this face. Okay, here you can see. So now I have I've added the fixtures, the force, and the connections and the material. Now it is time to just create the mesh. So here you have a beautiful slider to use. You can just keep it fine so that it will give you small things, and then also it will take more time in calculation. So just leave it here and click OK. So meshing will take some time. Whether you are applying any sorts of control over the model, like control is also something used to refine the mesh at some locations. You can use control as well. So wherever you think that you need to get more accuracy of the stress, strain, and those values, you can use control mesh. Okay, it is taking some bit of a time. So let me just show you whatever studies I've set up already, like static 1, fatigue 1, static 2, fatigue 2, static 3, and fatigue 3. Okay, it is just it is taking some time. Let me just show you what are the results. So in static study, we have applied material, connections, fixtures, loads, and mesh. So these are the control areas, and you can see here I have applied the control areas here, so that those fillets at the curvature points, the mesh is properly refined and the values are appropriately given. Once the mesh is completed, we'll just go to run the study here. So as I already used created results, let me just showcase the results. So here we have stress, displacement, strain, and factor of safety plots. So this is the stress plot, and here you can see the legend over here right side. It's beautifully giving the yield strength of the material. So this is the yield strength. In other words, the allowable stress of the material is 275 MPa, and when it is compared to our model is experiencing 214.283 megapascals at this region, which is well below this yield strength, and that says that in just static analysis our model is passed. And let us just see whether we can make some changes. You can see beautifully mesh has been shown, and you can also get values at each and every node, calculate those things. Anyway, this is the maximum value. and let's see whether we can animate it. You can see how it is animating. You can also create a video of it and place it in your presentations. And the displacement value is 4.28. So 4.28 is maximum at the color red. Okay, where there is the red color, it is maximum, and from red to green it is transiting like in a yellow color. It's not directly transitioning, it has a yellow color. Okay, let us just see the factor of safety. So the factor of safety is 1.28. So theoretically it is greater than 1, so it is good. Okay, when we compare just in static analysis, it is more than 1, so it is said to be perfect design. So let us evaluate the fatigue analysis. So here fatigue analysis is a little bit typical than so here you can see I want to create a fatigue study. So I'm just going into new study, selecting fatigue. So actually fatigue is just to see what is the life of the component, what is the sustainability of the component. So how much cycles or how much time is it going to last, and what is the damage over a period of time. That is the main motto of fatigue analysis. And of course the fatigue analysis will take the feed from static analysis. Without static analysis we cannot give the output the static analysis to fatigue analysis. That is the reason why we have created static analysis initially and then run fatigue analysis. So let us just create a new fatigue study from the static one. Okay, so we'll see, select fatigue analysis and click OK. Okay, so now you can see fatigue study is created. So it is asking about the properties. So here in fatigue analysis, based on these parameters, it is going to evaluate whether the stress obtained is good or not, if the factor of safety is good or not. So here we have some parameters like mean stress correction and alternating stresses, which are of prime importance in fatigue analysis. And of course we also calculate theoretically like hand calculations on mean stress and fatigue strength factor reducing factor. Fatigue strength reducing factor is also a factor which will define the life of the component, the fatigue life of the component, and where the crack is going to initiate over a period of time after the application of load, continuous load, or else there may be different types of application of the load. Okay, so here we need to add an event of and say that it has to last of, let's say, 7 lakh cycles, and we are keeping 0 based on LR is equal to 0. So these are actually fully reversed zero based loading ratios. Find cycle peaks are actually ways to interpret and tell SolidWorks that whether the load is cyclic load, or whether the load is cyclic plus compressive, or whether the load is cyclic plus tensile. So based on those cycles, these are going to be selected. 0 based, LR is equal to 1, LR is equal to 0. Okay, we are going to select this and click OK. So run this study. So I already have a study which I have already run it. So you can see fatigue fatigue 1. You can see, let me just show you the result of this. So in fatigue, we'll create actually 2 plots. That is one is a damage plot and another one is a life plot. So damage will tell you where is the damage most likely to happen, and you can see here clearly. You can also change it to discrete, so it will give you better understanding of the transition from where it is material has to be added, these things. So here it is happening. Let's see the life, and see the minimum life cycle it is going to sustain, and that too at this region is about 55 lakhs. That is 55 lakhs cycles. Okay, now let us see the static design too. So this is entirely a different study. So just activate it, and now you can see how it is changed. This is how actually I have set up it in a configuration so that we can use it here. So this is a study, and let's see what are the results of the design 2. This is actually entire design variation. This is a different variation. So let's see what is the stress, and the maximum stress is over here. Okay, the maximum stress is over here, and you can see 198.398 is the maximum stress in megapascals. So this is the equivalent stress actually, that is von Mises stress. Okay, so mostly we will consider the von Mises stress because it is the equivalent. Okay, so based on the application of the load, whether it is tensile or compressive, we'll consider whether the principal stress P1, P3 or P2. Okay, so let's see what is the factor of safety it has achieved. So it's good. It has achieved 1.38 factor of safety. That means it is more than 1, and is also good than the first design. This is the design 2. Let us now just investigate what is the fatigue study, and how many cycles it is going to sustain. What is the lifespan of this component? Because that is very crucial. Based on that only you will evaluate the product and give all the things in advertisements. So here you can see it is given me damage and life. Let me just show you the the life. See here you can see 6 crores. Earlier it was 55 lakhs. Now it is 6 crores 85 lakhs. Okay, so these many cycles it is going to sustain. So that is a very good thing. And let us go with the design 3. So in the design 2 you can see the factor of safety is also more than 1, and more than compared to static analysis 1, that is the first design. Now let us just compare it with the design 3. Let me activate the design. Now here let us see what is the stress it has obtained. You can see it's not showing in MPa. Let me just change this to MPa. Here megapascals. So here we have achieved 248.389, which is more, and it is actually less, but it is very close to the yield strength of this material, which will caution us that this is going to fail. And let us see in the fatigue analysis. Let's see factor of safety. Here you can see the factor of safety is 1.1, that is more than 1, but is very close to 1. So it's very non-reliable solution. Okay, let us just see what is the fatigue life and how many cycles is going to sustain life. So here you can see it is just very low, that is 6 lakhs, just 6 lakhs cycles. Earlier you have seen in the static study 3, for the design 2 you can see it is sustaining for you can see 6 crores 70 lakhs. It's a very huge number of cycles, and this design is actually proper for all the loading conditions which we have given, that is the 1350 newtons. Okay, 1350 newtons we have added the force. So based on all the things we have given hinged mates, because we know that these things are not going to stay stationary and fixed in all the degrees of freedom. We know that it is just going like a cycle crank when we are pedaling. So that is the reason why we have given hinged, and SolidWorks will know intelligently that if it is a hinged mate, then it is going to calculate accordingly. The results are according to that. And of course the mesh control which we have given will refine the mesh over here and give appropriate results. Okay, and so these are the things. So let us just go back to the presentation and summarize what are the results which we have obtained, and what is the best crank, and which is going to last longer, which design is going to last longer. Let us just see. Let's go back to the presentation. So in the first design, the question is about the durability. Which component is going to be sustained for a longer period of time. So here you can see whatever we are calculating here is completely equivalent stress and von Mises stress, and the maximum value of the stress is in the first design is 215 megapascal, which is well below the yield strength, that is the allowable stress of the material, and you can see where the crack is going to be initiated. The crack is going to be initiated there, and that is going to initiate after 55 lakhs cycles. 55 lakhs cycles. Okay, 55 lakh cycles, and the factor of safety we have obtained is above 1, that is 1.28. Okay, let us just go with the second iteration of the results. So here also you can see the stress concentration is over there, and we are you can see that we have obtained 198 megapascals of stress there, and 6 crores 67 lakhs of cycles. That is a very huge number, and we can say that it will sustain a volume of time, and the factor of safety is also greater than 1, and it is 1.4, and the values which we have taken is like theoretically we have considered 1 as the minimum factor of safety, and according to that only we have given the allowable stress values. Okay, so in the next iteration we have 248 megapascals, and it is just sustaining 6 lakhs cycles, which is low, and but you can see here in the fatigue study it is giving very small number of cycles, but in stress analysis it is passed. But it doesn't mean that stress analysis is enough, just structural static analysis is just enough. We cannot say that. So we need to go with some more parameters like fatigue analysis, where there are some more parameters to just evaluate those things, like mean stress correction. There are various methods of those things like Goodman, Gerber. So these are the people who did research on fatigue analysis. Okay. So based on all these 3 iterations, let us just summarize which design is going to last long based on the structural analysis and the fatigue analysis. So clearly the first design is passed, but when it is compared to design 2, it is giving less factor of safety and also less number of cycles, which will ultimately predict the life of the component. And of course the stress is also the calculated stress, that is 215 megapascal, is also not considered taken into consideration, because we are considering the life of the component. So design 3 is also failed, and ultimately design 2 is passed. And you can see what is the design tool is looking like. Okay, so you can say why what has actually happened. It is completely how you add material and remove material, how you make the design. So apart from this, SolidWorks is not only constrained to only CAD or simulation. It will give you complete detailed set of solutions according to our industries, which is booming. So you can see initially we have 3D CAD, which will just suits your mechanical CAD models, creations, everything using SolidWorks CAD. Next we have simulation. In simulation you have various modules like flow, plastics, and thermal analysis, frequency analysis, structural analysis, drop test, various things, and it is like a package simulation separate application. You need to purchase SolidWorks simulation for that, which is again integrated to SolidWorks. How beautiful it is, like now it is integrated to SolidWorks 3D CAD. You can perform validation seamlessly. And electrical, so electrical people need not worry. Detailed list of wires, lengths, colors, distinguishing, and proper list, creation of the list, connector list, all the things can be seamlessly created using SolidWorks electrical. And not only SolidWorks electrical, but also in SolidWorks CAD you have so many tools for that. Apart from that, apart from the 3D CAD and simulation and electrical, SolidWorks has some more detailed set of tools like technical communication. You can create using composers. You can create assembly, disassembling and assembling the videos, and render those videos, and easily you can create a browsers from that. And even if a normal person reads it, he can easily understand what component is that, where it has to be placed, etc. So it is more reachable to the general audience. And coming to the next one, that is SolidWorks Visualize. Visualize is a beautiful tool which is integrated with 3D CAD, which will take all your designs and render it, and it is one of the industry standards rendering tool. It is bounded with one of the industry standards visualization tool. That's a very great point, and you can utilize those things. One thing you cannot obtain with other rendering tools is the integration time to the market. You cannot be so fast to the market when your design is in SolidWorks and then you want to visualize it. If you use SolidWorks Visualize only, you can integrate it with very less time, and you can be very fast to the market and reach the deadline. That's the important thing. Next, you have product data management. In product data management, if you are working in teams, you can use product data management. It is SolidWorks PDM, which is separate added application. So you can easily create revisions of your works. You can set up who vaults, who is logging in, who is logging out, what is the time period allocated to him. So everything can be managed in SolidWorks PDM, that is product data management, which is a lifecycle management tool. And next we have SolidWorks CAM. How beautiful it is that SolidWorks CAD is now integrated with SolidWorks CAM. Everything is integrated, like whatever you create in CAD, you now integrated with CAM, and you can easily create NC coding. You can say in other softwares also it is created, but the workflow here is very beautiful. Okay, and small changes, you need to do small changes according to the tool path. So you can easily create the changes in the CAD, and you can observe that the CAM toolpath has been changed. That's a game changer. So that's all for this session, guys.